In this lesson, we'll be looking at modeling with quadratic functions. In the past, we have modeled some different situations with linear equations, and now we'll look at some situations where we can use quadratic functions. So let's just jump right into this, and we'll see where this comes up. So example 1, Philip plans to construct a dog pen off the back of his garage using its back wall as one side, and constructing the rest of the rectangular pen from 28 feet of fencing. Determine the maximum area of a pen and its corresponding dimensions. So what we have here, it's often helpful to sketch this. So here's the back of his garage. Just make that a little bit thicker. So that's the back of his garage. And he wants to put a rectangular closed-in area here to allow Rover to run around in. So we know that the fence part is 28 feet. So what we're going to do here is we're going to think through how we can label this thing. So we need to use up to 28 feet along the fence. Well, we want to maximize the area. It's good to look at what we're maximizing. So what is the area of a rectangular enclosure or a rectangle? And that we know that's base times height. And so what we do this is we put it in function form, area in terms of x, which we'll have to figure out what x is. So let's come over here. Let's just name this x. Let's name our width x, which means our length would have to be the 28 feet minus 2x. So we have the entire 28 feet for this whole thing, but we're using up x on the left side and we're using x on the right side, so we have 28 minus 2x. So here's our base, and here is our height, or some people like to think length and width. So our base is 28 minus 2x, and our height is x. And so now we have a formula for the area in terms of x. So what we're going to do here is we're going to multiply this out. So we have 28x minus 2x squared. And we want to graph this. So this is going to be a function that represents the area. We're not going to do this every time, but if you think about this, if we let the x be 1 foot, the height would be 1 foot, we could find the area of a pen if it was 1 foot here and then a really long pen. But what we want to do is we want to maximize the area. We want to find the highest possible area. Well, by now we're familiar with quadratics. We like to put the quadratic term first. So negative 2x squared plus 28x. And then let's go ahead and graph this. So remember what we do. We factor out this negative 2 out of both terms. So there's x squared factoring a negative 2 out of 28 is negative 14x. We leave a space to complete the square. Sometimes there's a constant out here. There's nothing there right now. And that's okay. So we take half of negative 14, which is negative 7. Negative 7 squared is 49. So we added 49, but actually remember we have to look out front here. And we added 49 times negative 2, which is actually negative 98. So if we subtracted 98, we need to add 98 out here. Now that's larger than the terms we usually work with, but that's okay. So now we have a of x equals negative 2, and then this is x minus 7 squared plus 98. So there's our area function, represents the area. Now we can graph this, and we're just going to estimate some things here, or on our graph anyway. So we know this is right 7 and up 98. Now I'm not going to make 98 marks, but I'll just say we're over 7 and up 98. We know this is facing downward because of the negative. And so we don't need it exact, because what we can recognize here is this function represents area. Our highest area occurs right here. And when is that? Well, that is when x was 7. So to answer the question, determine the maximum area of the pen and its corresponding dimensions. Well, we'll find both of those things. So we know the maximum area is 98. and this is in feet squared. And then the dimensions, well, the dimensions, we know x is 7, so we put a 7 in here. Well, if that's 7 and this is 7, oops, this is 28 minus 2x. I wrote that wrong a long time ago. I wrote it correct here, but wrong over there. So 28 minus 2 times 7 is 28 minus 14, which is 14. So our dimensions are 7 feet by 14 feet. And so with the 28 feet of fencing that Philip has, he can make a pen that is 7 feet by 14 feet, which will give a total of 98 feet squared for the pen.